Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Now make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have x to the power of x to the power of 6 is equal to 144. So I want to find the value of x. So to start, I'm going to take the power of 6 on both sides. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n, these two are interchangeable, meaning this is the same thing as a to the power of n times m. So now, if a to the power of m times n is the same thing as a to the power of m to the power of n, then a to the power of n times m, this has to equal a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, we have x to the power of x to the power of 6 to the power of 6. We can think of x to the power of 6 as m and 6 as n. So now we can switch these two places. So now we have x to the power of 6 to the power of x to the power of 6. Now this is equal to 144 to the power of 6. Now I'm going to let x to the power of 6 equal the variable y. So now I have y to the power of y is equal to 144 to the power of 6. Now 144, this is the same thing as 12 to the power of 2. So now I have 12 to the power of 2 to the power of 6. And remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 times 6 is 12, so I have y to the power of y is equal to 12 to the power of 12. Now if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, y is equal to 12. However, remember, we're not solving for y, we're solving for x. And x to the power of 6 equals y. So now that we know that y is 12, this means that x to the power of 6 is equal to 12. So now, to solve this, I'm going to take the power of 1 over 6 on both sides. So now I have x to the power of 6 to the power of 1 over 6 is equal to 12 to the power of 1 over 6. Now 6 times 1 over 6, these two cancel out. So now I'm left with x is equal to 12 to the power of 1 over 6. So this is my answer. Alright, so I have 2 to the power of 20 minus 1. Now 20 here, we can rewrite this as 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. Now if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 10 times 2, that's going to equal 2 to the power of 10 to the power of 2. Now I have this minus 1. So now 1 here, this is the same thing as 1 squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10, and b is equal to 1. So I have 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now, 2 to the power of 10, this is equal to 1024. So now I have 1024 plus 1 times 1024 minus 1. 1024 plus 1, that's going to be equal to 1025. And 1024 minus 1, that's equal to 1023. So now I'm left with 1025 times 1023. So now, let's go ahead and evaluate this. Well, first off, 1025, to make this simpler, we can rewrite this as 1000 plus 25. And 1023, we can rewrite this as 1000 plus 23. So now we have 1000 plus 25 times 1000 plus 23. So to solve this, I'm going to start by distributing the 1000. So now I have 1000 squared plus 23 times 1000 plus 25 times 1000 plus 25 times 23. So now 1000 squared, that's going to equal 1 million, plus 23 times 1000 is 23,000, 25 times 1000 is 25,000, and 25 times 23, that's going to be 575. So now if you add all of these together, you get 1,048,575. So this is my answer. All right, so I have x to the power of x to the power of 2 is equal to 16. So I want to find the value of x here. For my solution, first start with x to the power of x to the power of 2 is equal to 16. Now I'm going to take the power of 2 on both sides. So now I have x to the power of x to the power of 2 to the power of 2 is equal to 16 to the power of 2. Important property of exponents is that if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And m and n, these two are interchangeable, meaning a to the power of m times n, this is the same thing as a to the power of n times m. So if a to the power of m times n is equal to a to the power of m to the power of n, then this means that a to the power of n times m, this is equal to a to the power of n to the power of n. So in simpler terms, a to the power of m to the power of n, this is equal to a to the power of n to the power of n. So right here we have x to the power of x to the power of 2 to the power of 2 is equal to 16 to the power of 2. So we can think of x to the power of 2 as m and 2 as n. So this is the same thing as a to the power of n to the power of m, meaning if we change these two places, it's going to equal x to the power of 2 to the power of x to the power of 2, which is equal to 16 to the power of 2. Now I'm going to let x to the power of 2 equal to the variable y. So now I have y to the power of y is equal to 16 to the power of 2. Now 16, this is the same thing as 4 to the power of 2. So now I have y to the power of y is equal to 4 to the power of 2 to the power of 2. Now if we go back, remember how if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 4 to the power of 2 to the power of 2 to the power of 2, that's going to equal 4 to the power of 2 times 2. And 2 times 2, that's equal to 4. So I have y to the power of y is equal to 4 to the power of 4. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, y is equal to 4. However, remember, we're solving for the value of x. So if x squared is equal to y and y equals 4, this means that x squared is equal to 4. So now to solve this, I'm going to take the square root on both sides. These two cancel out. Now I'm left with x is equal to positive or negative 2. So this is my answer. Alright, so in this problem, I have 4 to the power of x is equal to 12. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 4 to the power of x is equal to log 12. Now if I have something in the form log a to the power of b, this is equal to b times log a, because all I have to do is simply move my exponent to the front. So for log 4 to the power of x, I can move x to the front. So this is going to equal x times log 4 is equal to log 12. Now we obviously want to isolate x here, so
To do that, I have to get rid of this log 4 by dividing on both sides. So then these two cancel out, and now I have x is equal to log 12 over log 4. Now, log 12, that's equal to log 4 times 3. Now I have this over log 4. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 4 times 3, that's going to equal log 4 plus log 3 over log 4. And this is equal to log 4 over log 4 plus log 3 over log 4. Now log 4 and log 4, these two cancel out. So now I have 1 plus log 3 over log 4. Now log 4, that's equal to 2 squared. So I have x is equal to 1 plus log 3 over log 2 squared. And log 2 squared, that's the same thing as 2 times log 2. Now log 3 is equal to 0.4771. And log 2, this is equal to 0.301. So now I have x is equal to 1 plus 0.4771 over 2 times 0.301. And this is equal to 1 plus 0.7925, which is equal to 1.7925. Alright, so in this problem, I have 4 to the power of x plus 16 to the power of x is equal to 64 to the power of x. Now, 16, I can rewrite as 4 squared. So now I have 4 to the power of x plus 4 squared to the power of x. And now 64, I can rewrite as 4 to the power of 3. Now, I'm going to rewrite this as 4 to the power of x squared. 4 to the power of x plus 4 to the power of x squared is equal to 4 to the power of x to the power of 3, because I can switch the places of these two. Now, I'm going to let 4 to the power of x equal to the variable u. So now I have u plus u squared is equal to u to the power of 3. Now to solve this, I'm going to start by factoring out, I'm going to start by subtracting u squared and u on both sides. So then these two cancel out, and now I have u to the power of 3 minus u squared minus u is equal to 0. Now I can factor out u, so I have u times u squared minus u minus 1 is equal to 0. Now to solve this, I can divide this into two parts. U equals 0, and u squared minus u minus 1 is equal to 0. So u equals 0, this is already a solution. And to solve u squared minus u minus 1 equals 0, we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So I'm not going to waste your time actually plugging in everything into the quadratic formula, but you should end up getting u equals 1 plus the square root of 5 over 2. And u is equal to 1 minus the square root of 5 over 2. So now, remember how we set 4 to the power of x equal to u. So first, I have 4 to the power of x equals 0, and there's no solution to this because you can't take the power of a number and make it equal to 0. So now I have 4 to the power of x is equal to 1 plus the square root of 5 over 2, and 4 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 is going to be a negative number, and you can't take the power of a positive number and make it negative, so this is no solution as well. So I have left with 4 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So now I have x times log 4 is equal to log of 1 plus the square root of 5 over 2. Now if I divide both sides by log 4, these two cancel out and I get x is equal to log of 1 plus the square root of 5 over 2 over log 4. Alright, so in this problem, I have 7 to the power of x plus 8 is equal to 8 to the power of x plus 7. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of x plus 8, that's going to equal 7 to the power of x times 7 to the power of 8. And a to the power of x plus 7, that's going to equal a to the power of x times a to the power of 7. Now I'm going to divide both sides by 7 to the power of 8 times a to the power of x. So then these two cancel out and these two cancel out. And I'm left with 7 to the power of x over 8 to the power of x is equal to 8 to the power of 7 over 7 to the power of 8. Now this is the same thing as 7 over 8 to the power of x is equal to 8 to the power of 7 over 7 to the power of 8. And now I'm going to take the log on both sides. So now I have log 7 over 8 to the power of x is equal to log of 8 to the power of 7 over 7 to the power of 8. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So log of 7 over 8 to the power of x, I can move x to the power of front. So now I have x times log 7 over 8 is equal to log of 8 to the power of 7 over 7 to the power of 8. Now log of a over b, this is equal to log a minus log b. So log of 7 over 8, that's going to equal log of 7 minus log 8, which is equal to log of 8 to the power of 7 minus log of 7 to the power of 8. Now if I divide both sides by log 7 minus log 8, these two cancel out, and now I have x is equal to 7 times log 8, because remember I can move the exponent to the front of both of these, minus 8 times log 7 over log 7 minus log 8. And from here, if you plug in all the values of log 8 and log 7 into the equation, you get x is equal to negative 0.4399.